For literally thousands of years, we've thought of prime numbers as these lonely, random atoms of arithmetic. But what if that's just completely wrong? Today, we're going to dive into a pretty radical theory that says primes aren't random at all, not even close. In fact, they might be the quietest points in a universe that's just humming with a hidden mathematical vibration.
So, to really get our heads around this, I want you to think about a pretty strange question. What is the sound of a prime number? I know, it sounds kind of nonsensical, right? But stick with me, because it's the perfect way to start uncovering this deep, deep connection between the numbers that build our world and the physics of waves and vibrations.
All right, so first things first, we need to ground all this in something we can actually picture. Let's talk about the world of music and physics, and we're going to start with something super simple, a single vibrating string, like on a guitar.
Okay, so picture a guitar string. You press your finger down at one spot, right? And you get a specific note. But here's the really cool part. There's always a mirror position on that same string that creates a related, complementary note. It's like every sound has a hidden twin. And this idea of symmetrical pairs creating resonance, that is the absolute key to everything we're about to talk about. So remember that.
Okay, you with me so far? We've got this idea of resonance and symmetry on a string. Now we're going to do something a little wild. We're going to take that exact same thinking and apply it not to a physical object, but to the abstract number line itself.
And this right here is the central leap of what's called the prime wave theory. It asks us to imagine that numbers aren't just, dots on a line. Instead, they occupy a kind of field, and that field can actually have a shape. It can be totally flat, or it can be curved. Okay, this slide, this is it. This is the core thesis, right here. The theory goes like this. Prime numbers exist in the parts of this field that are perfectly flat. They have zero curvature. They create a kind of mathematical silence. Composite numbers, on the other hand, are curved. Their very nature creates a disturbance, a resonance. The big question is, how?
Well, here's the crucial point. The curvature of a composite number comes from its divisors. So think about a number like 6. Its divisors are 2 and 3, right? In this theory, they act like two little stones dropped in a pond. Each one creates waves, and those waves ripple out and interfere with each other. And what do you get? A complex, noisy, or, you guessed it, curved pattern.
Now, this whole distinction between flat primes and curved composites, it's not just a nice metaphor. No, there's a specific mathematical tool that actually acts like a detector for this exact property. Let's dig into how that works.
Okay, it's called the number curvature functional, which is a bit of a mouthful. It's represented by the Greek letter kappa. But honestly, you don't need to worry about any complex formulas. Just think of it like a simple on-off switch. If a number is prime, kappa is 0. The curvature switch is off. The field is flat. But if a number is composite, kappa is greater than 0. The switch flicks on and the field gets curved. Simple as that.
Let's walk through a quick example. Take the number 6. We know its proper divisors, 2 and 3, create those interfering waves. And the result is a curved field. Okay, now look at the prime number 7. Does it have any proper divisors to create waves? Nope. So there's no interference, nothing at all to disturb the field. The result is perfect flatness, perfect silence. And that's it. That is the sound of a prime number. Silence.
So think about this for a second. If numbers have an actual physical property like curvature, the implications are just staggering. It means we might be able to describe the abstract rules of arithmetic using the language of physics.
In physics, there's this concept called a Lagrangian. It's basically an equation that describes the total energy of a system. And this theory proposes one for the number line itself. Put as simply as possible, it basically says that being a composite number costs energy. It's like it creates a disturbance that nature has to pay for. And since nature always seeks the lowest energy state, the path of least resistance, it inherently prefers the primes. They are the calm, stable, low energy states of this whole number field.
And the consequence of that is just profound. Suddenly, we can treat the totally abstract world of numbers as a real physical system. A system where we can measure its energy, calculate forces, and even track conserved currents that flow through it, almost like electricity flowing through a wire. It's wild.
And believe it or not, this isn't just some philosophical thought experiment. It has some stunningly practical connections. Get this, a core law of physics, Noether's theorem, actually predicts energy spikes exactly where the prime numbers are. It even connects to quantum computing algorithms that are being developed right now. But maybe the most incredible part, This whole theory is testable. I mean, actually testable in a lab. Scientists could potentially build special acoustic chambers, or use supercooled atoms to try and literally hear the resonance structure of the number line.
Okay, so let's pull back for a moment and just think about what this all means. If numbers themselves have a physical structure, what does that say about the universe that they describe?
We already have some pretty tantalizing hints that this isn't just pure fantasy. Take a look at something called the Ulam spiral. When you arrange all the integers in a spiral, the primes, well, they don't appear randomly at all. They mysteriously line up along these diagonal lines. It's something that has baffled mathematicians for decades, but it's exactly the kind of non-random structure that this prime wave theory would predict.
There's a quote from the source material that just perfectly captures this huge shift in perspective. Prime numbers are not random, they are the silent anchors of the harmonic field. So they're no longer these random, isolated oddities. They're the fundamental, stable anchors in this dynamic, vibrating field of numbers. They're the points of complete stillness that give structure to the whole shebang.
And that brings us right back to where we started. Maybe the universe isn't just built with math, but math itself has a physical structure, a kind of harmony. And if that's true, then it makes you wonder, doesn't it? Are the prime numbers the silent, foundational notes of that hidden cosmic song?